We're going to be talking about the angles of polygons. What is a polygon? Don't overthink it. What does it look like? A polygon. It's a shape. That's all. A shape with closed sides, straight lines, all that stuff. So we're going to talk about the insides of the polygon, the inside angles, and then we're going to talk about the exterior angles of a polygon first. All right, so in order to do that, we gotta show you the pattern. But you have like a fill in the blank in the top. In a polygon, two vertices that are endpoints of the same side are called consecutive vertices. I will show you why it matters here in a minute. Pick a vertex in this polygon. Any vertex. A, B, C, D, E. Which one? C. All right, so a consecutive vertex are the vertices that share a side. So what is consecutive with C? B and D. Those are consecutive. Here's why that matters. We're going to draw diagonals here in a second, and diagonals are drawn between non-consecutive sides. So that is the blank there. A diagonal of a polygon is a segment that joins two non-consecutive vertices. So from C, what is a non-consecutive vertex? A. So we could draw a diagonal from C to A. And then what is the other diagonal we could draw? E. Why did we do this, Ms. Marshall? Because here's why. When you draw diagonals like this, you see three of a certain shape. And what shape is that? A triangle. How many degrees are in a triangle? 180. So if there's 180 in this triangle, and 180 in this triangle, and 180 in this triangle, that tells you how many degrees are in the outer shape. So how many degrees would be in my five-sided shape if I have three triangles? What's 3 times 180? It's 540 degrees. So because three triangles fit inside of this shape, 3 times 180 degrees, because each of them have 180, make 540 degrees. So how many less triangles, or how many triangles were there in comparison to the number of sides? So there are 5 sides. How many triangles were there? 3. So how many less triangles are there than sides? 2. That's the pattern we're going to see here. I'll show you with these 4 shapes. So we got a triangle. How many triangles are in one triangle? Just the one, and it's 180 degrees. All right? In a quadrilateral, how many triangles are there going to be? There's going to be 2. So how many degrees are in a quadrilateral? 360 degrees. The next one has 5 sides. Pick any of the vertices. You got top, you got left, right, bottom, left, bottom, right. Which one? You want to use the top? All right, how many diagonals or how many triangles can I draw from the top there? 2 diagonals, which makes 3 triangles. So 3 triangles, 180 apiece. We figured that out. That is 540. And then the last one, how many triangles am I going to have? Triangles, 4 triangles, 180, 180, 180, 180. So 4 triangles, they're 180 degrees apiece. That makes, just put it down. It makes 720 degrees. So why did we do it like this, Miss Marshall? Because you're going to see a pattern here to figure out how many degrees are in each shape. So a triangle had 3 sides, and 1 triangle was in a triangle. That made 180 degrees. A quadrilateral had 4 sides. How many triangles were inside of that? 2, which makes 360 degrees. A pentagon has 5 sides. How many triangles were inside the pentagon? 3. And at 180 apiece, that makes 540. A hexagon has 6 sides, and there were 4 triangles inside of that. 4 times 180 makes 720. So what is the pattern? What is the correlation between the number of sides and the number of triangles? How many fewer triangles are there than sides? 2. Every single time. If there were 3 sides, there was 1 triangle. If there were 4 sides, there were 2 triangles. So what's going to happen is you're going to take the number of sides, so any polygon, this just represents any polygon, you're going to take the number of sides and figure out how many triangles there are inside of that shape. You do that by n minus 2. N minus 2 represents the number of triangles. You take the number of sides and subtract 2. And then once you find the number of triangles, you multiply times 180. So n minus 2 times 180 is your last blank. I would highlight it, and then I would highlight this phrase up here, the sum of the measures of the interior angles. So for any polygon, you can find the sum, meaning what all of them add up to, of the inside angles of any polygon by n minus 2 times 180. So n minus 2 times 180. All right, so we're going to practice here. Go ahead and highlight again the phrase, find the sum of the measures of the interior angles. Anytime you see that phrase, it means what do all of the inside angles add up to? And in order to figure that out, you do n minus 2 times 180. What does n represent? The number of sides. So in an octagon, how many sides are there? 8 sides. So how many triangles are there going to be in an 8-sided shape? 6 triangles. They're 180 apiece. So 6 times 180 makes 1,080 degrees. So in every single octagon, that's how many degrees are inside. So 15-gon, how many sides does 15-gon have? 15. So how many triangles are inside of a 15-gon? 13 triangles times 180, 2,340 degrees. So for every single 15-gon, it's 2,340 degrees. You are going to do the 24-gon. So how many triangles are in a 24-gon? Well, how many triangles? 22 triangles, 180 apiece. So how many degrees is that? 3,960 degrees. Perfect. Go ahead and flip to the next page. You'll be asked to do the opposite, where I give you the degrees, and then you have to tell me what the shape was. So we're going to do the opposite as well. In order to do that, you'll have to know the names of the shapes. So if you notice 15-gon, 24-gon, there's a certain point where you can just write the number and gon. They technically have names. A 15-gon is a Pentagon. Like, they have names, but you're not required to know them after 12. So you have this list. The first one, of course, a 3-sided shape is called a triangle. So we are on page 2. What is the official name of a 4-sided polygon? Quadrilateral. A 5-sided shape? Pentagon. A 6-sided shape? A hexagon. 7-sided shape? Heptagon. Heptagon. So they both have H's. Heptagon. 8-sided shapes, obviously. Octagon. A 9-sided shape. Nonagon. Ten sides. Decagon. $11. Pendecagon. So you use a prefix and then decagon in the teens. And then 12-sided dodecagon. So you're required to know these this list. After that, you can write the number and then gon. So 13 gon, 14 gon, 15 gon. They technically have names. If you wanted bonus points on like a quiz or a test and the answer was a 13 gon and you put tridecagon, I would give you those bonus points. So it's up to you. I've had a student who before memorized up to 30 because they really wanted the bonus points. So it's up to you. But anytime it's a teen, they're pretty easy, other than 14 is tetradecagon, which is weird. But pentadecagon is 15, hexadecagon is 16, and so on. All the way up to 20, which is icosagon. Questions on the names? Okay. We're going to work backwards this time. It says the sum of the measures of the interior angles is given. So the sum is how many degrees are inside of a shape. We got to figure out what shape it was. So normally you use n minus 2 times 180, and it would give me the sum of the interior angles. For this example, what is the sum of the inside angles? That 900. So we got to work backwards to find out what n was, what the number of sides was. So what would I do first? Divide by 180. Most people do this really well, the dividing by 180. It's the next step that they usually, if they get it wrong, this is where they go wrong. So you have n minus 2 equals, what's 900 divided by 180? It's 5, yeah? All right, and then this last step, you have to add 2. A lot of people try subtracting 2, which would mean a triangle, which is not 900 degrees. But n equals 7. Remember that it said classify the polygon. So we have not answered the question if you just tell me the number of sides. We have to actually tell me what shape it is. It has 7 sides. What do we call a 7-sided shape? A heptagon. So your answer is heptagon. We'll practice again at number 5. N minus 2 times 180 gave us the number 1620. Divide by 180. What is 1620 divided by 180? It is 9. So then add 2. The number of sides is 11. Then we have to classify it. What is that classified as? A hendecagon. Hendecagon. You are going to do number 6. So 2,880. We're going to figure out how many degrees are inside. So a lot of pencils are going down. What did we get as our answer? 18 gone. Good. Which would be an octadecagon if you wrote down the real name. Octadecagon. Good. So when you're ready, we can turn to the next page. We're going to actually use this in a problem. It says find the value of x. So we need to know how many degrees are inside of these shapes before we can figure out what x is. So to figure out how many degrees are inside, you can do n minus 2 times 180. Someone asked earlier if they could just memorize. You can if you wish. But I'm going to tell you on your test, they're going to be larger numbers, and you can't just memorize. You have to know how to do it. But how many sides are on this first shape? 4. So you could memorize how many degrees are in a 4-sided shape if you want. How many degrees are in a quadrilateral? 360. If you didn't know that, that's fine. You would just figure out how many triangles there are. There are 2 triangles in the shape, 180 apiece. That means there's 360 degrees inside of every quadrilateral. So we will add 45 plus 65 plus 95 plus x, and it will equal 360. Combine your like terms. What's 45 plus 65 plus 95? 205 plus x equals 360. Subtract the 205. What is 360 minus 205? 100 what? 55. Are there any questions on this one? Okay. The second, how many sides are there? 6 sides. So we need to figure out how many degrees are in a 6-sided shape. So 6 minus 2 times 180. How many triangles are in a 6-sided shape? 4 triangles times 180, which means how many degrees? 720. So we're going to add a lot of numbers and set it equal to 720. So I'll start with x because I want to. Oop. X plus 140 plus 130 plus 120. The most common mistake on this question is forgetting about 90 plus 90 plus 150. And all of that equals 720. So you want to make sure you have all 6 angles added up so it's equal to 720. Combine like terms. What is 140 plus 130 plus 120 plus 90? 630. Do we all agree? Perfect. So plus 630. Subtract the 630 from both sides, which means the remaining angle has to be 90 degrees. 90 degrees. Questions on this one? Okay. We're going to skip the bottom one for now because it'll be reviewed for tomorrow. This is the last thing we talk about before we do whiteboards. This problem right here. I want you to take your highlighter. The sum of the measures of the exterior angles is 360. So when you add all the exterior angles, they equal 360. Does it say for a certain shape? It does not, because it's for all shapes. It doesn't matter how many sides there are. If you took each angle and lined them up, they make 360 degrees. What does 360 look like in real life? Looks like a circle. If you look at this example over here, it's like, it's me colorizing it kind of for you. If you take all of the exterior angles, this one has more sides, as 1, 2, 3, 4, 5, 6, 7, 8 sides. If you took all of the outside angles and you combined them and put them in the vertex in the same place, they make a full circle together. So that's where this property comes in. Doesn't matter how many sides there are, they will add up 360, the exterior angles. So we're going to use that property here in this example. All of the exterior angles add up and equal 360. So 4x plus 98 plus x plus 162 equals 360. So combine your like terms. We obviously have 4x and x, which make 5x. But what is 98 plus 162? 260. So subtract the 260 on both sides. So then 5x equals 100. So then x is 20. 20. So don't put your notes away because we'll have time to talk about the 3 words at the top of the next page. But we're going to practice on our whiteboards. Go ahead and take out your whiteboard and your marker. When you have the answer, you can just show it to me, and then I'll tell you yes or no. But here's the first. Find the sum of the measures of the interior angles of a heptagon. So again, we will be using these notes again, so don't put them away, because we'll go back to them in a minute. Find the sum of the interior angles of a heptagon. Correct. When you got it, you can show it to me. Good, 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 good. Good, good. All right, so how many sides does a heptagon have? 7. So if it has 7 sides, you can use the 7 minus 2 times 180. How many triangles are inside of a heptagon? 5 triangles, 180 apiece. You get 900 degrees. All right, number 2, you're going to do the opposite. The sum of the interior angles is given. It's 3060. You're going to classify the polygon by the number of sides. $3,060. Yes. Correct. 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 So you're working your way backwards. Good. Good. So use n minus 2 times 180 to work your way backwards. What would you do first? Divide by 180, which makes 17, yeah? Add 2, so the number of sides is 19. You would say 19 gone. Non-Dodecahedron. You'd put an A in between, but yeah. Non-Dodecahedron. Good. Number 3, find the value of x. So you first need to know how many degrees are inside of the shape, and then go from there. Yes, good. 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 Not quite. It's close. Good. So how many degrees are inside of a hexagon? This is a hexagon, isn't it? There's 720, right? 4 triangles times 180 is 720. Add them up, set m equals 720, you get x equals 125. So 125. Find the value of x. Where are these angles located? On the outside. So remember, these are actually easier than the interior angles. Less work. Correct. Good. 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 So how many degrees do all of these add up to? 360. So you can add x and x, which makes 2x. And then you can add 60, 64, 36, and 48. What did that make? 208. Subtract it, divide by 2, and x equals 76. Good. Number 5, find the value of x. You're correct. Correct. Yes. Good. Correct. Good. Yes. Good. So how many degrees do these exterior angles add up to? 360. So the number one thing that I see people get wrong, even in first hour, make sure, how many outside angles do you have? There's 4 of them. So a lot of people forget about this 90 over here, and it will change your answer by 90 degrees. So make sure you got that. They add up and they equal 360. So then eventually you get x equals 88. We are almost finished with these whiteboards. We have 3 left, including this one. Find the value of x. So these are interior angles. So find the sum of the interior angles. Correct, correct. Correct. I think you're missing an angle. I think you're missing an angle. That's good. Correct. So you should add all of them up. How many angles are there? How many angles? There's 5 angles. So the number one thing that I see people do, and I saw a couple do, is they forgot 90. So make sure you add all 5 angles that equal 540. So then eventually you get x equals 84. So if you got 174, that means you forgot the 90. So make sure you add in the 90. All right, we got 2 more. Find the measures of x and y. What do we know about angle x and angle y? They are consecutive, yes. What do we know about their measures? They're congruent, right? That's what those arcs mean. So they're the same. So what do you want to call them both if they're the same measure? You can call them both X if you want. You can call them both question marks if you want. But either way, you got to figure out how many degrees are inside of this shape and then find the value of X. Not quite. Yes, sorry. Not quite. What'd you get, Addison? Yeah, it's good. Good. Not quite. Yes. So 90, correct, plus 120. You can call them 2x if you want, because x plus x makes 2x, equals 360 degrees. You add them, subtract, then divide by 2. You get x equals 75. 75. One more before we go back to our notes really quick. Find the measures of angle x and angle y. Correct. 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 Good, good, good. Good. So, how many sides are there? 6 sides. So how many triangles are inside of this shape? There's 4 triangles times 180 makes 720. So add all of the angles and they will equal 720. I called them X and X, these missing angles. You can also do part of it in your head. But once you subtract all of the other angles and then divide by 2, that means each of the angles is 135 degrees. Okay, you can put your board aside. We're going to do a little bit more notes and then just be done for the day. So we're on page 5. There are 3 words at the top. One of them is super important. The other 2 kind of gear you up for the last one. What do you notice in the first picture? All the sides are congruent. What did we call a triangle where all the sides were congruent? Equilateral. So that's what we call any polygon with all equal sides. Equilateral. In the next picture, all of the angles are the same. So what do we call a shape with all the angles being the same? Equiangular. Good. Equiangular. The last one is the new word, and it's the one you need to know. And we're going to highlight it here in a second. So if you look, how many sides are in the first shape? 6 sides, which makes it a hexagon, right? All right, the second shape, how many sides are there? Still 6, and it makes it a hexagon, right? This last one still has 6, right? But it has all equal sides and all equal angles. This is what we call a regular polygon, and I would highlight it. A regular polygon. There are so many ways a hexagon can look, but if you want the classic polygon, where the sides are all the same length, all the angles are the same, we call it regular. And I would highlight that because we're going to solve problems where all the angles are the same, where they're regular. Okay? So a regular polygon. Think about, what does a regular quadrilateral look like, where all the sides are congruent and all the angles are congruent? A square is a regular, right? When you think of a pentagon that is regular, it looks like a house. What does a regular octagon look like? A stop sign. Okay, so those are the classic ones you see in everyday life. We'll do this one tomorrow. We're going to do these just on this page. It's like a diamond type thing. You're going to take your highlighter. Each face of the dodecahedron is shaped like a regular pentagon. Go ahead and highlight regular pentagon. And then we're going to highlight one of them. So highlight the front one. Dodecahedron is a three-dimensional shape. You don't really need to know much about it. But the face of each of these, think this looks like a soccer ball if you really thought about it. But we're going to find the measure of each interior angle of a regular pentagon. I would highlight those words. Each interior angle of a regular pentagon. So we want to figure out what an individual angle is on the inside of this regular pentagon. So the first thing you need to know is the sum of the interior angles. Because the sum is how many degrees there are in general, right? And then we want to be able to split it evenly between the number of angles. That's our goal. Find how many degrees there are in general, and then divide it evenly between the number of angles. And that's how we find each interior angle in a regular pentagon or any shape in general. So first we need to figure out the sum of the inside angles. How many degrees fit inside of this shape? So how do we figure out the sum of any inside angle of any pentagon, or any polygon, I mean? N minus 2 times 180. So that's how we're going to figure out that top number. N minus 2 times 180. So a pentagon has 5 sides. So 5 minus 2. How many triangles are in a pentagon? 3 times 180. So what is the sum of the exterior angles? 540. So we know there's 540 degrees between all 3 of these angles. All right, but we also know all of the angles are congruent. So we're going to split it 540 by the number of angles. So how many angles are in a pentagon? 5. So each individual angle, what's 540 divided by 5? 100 what? 108. Okay. So each inside angle is 108 degrees. If you added 108 plus 108 plus 108 plus 108 plus 108, that makes 540 degrees. Questions on this one? So the common thing is that people just don't understand the directions. Anytime you see the word regular and the word each, this is the process that you do. Okay, you're going to find each individual. The second is a lot simpler. Find the measure of each exterior angle, still of a regular pentagon. It's the same process, just the top number is easier to figure out. We're going to take the sum of the exterior angles, and then still divide by the number of angles. We want to figure out how many degrees each exterior angle is. So what is the sum of the outside angles of any shape? 360. There's no math involved. There's 360 degrees when you combine all the exterior angles, and then divide it evenly between the number of angles in a pentagon. So still dividing by 5. What is the measure of each outside angle? Should be 72. A good way to check yourself is, what is 108 plus 72? It makes 180. Here's why. If I were to extend each of these angles, did I do it right? Nope. Here's the exterior. Here's the exterior. Here's the exterior. So I highlighted the exterior angles. Is everyone okay with them? They're in purple. Okay. They're a linear pair with the interior angle. So you should always add up to 180. It's kind of a way you can check yourself.